You are welcome to Asanje Academy for Global Conquest. This is an e-platform for learning, and we have a lot of content. We have lots of content for you. So if you go through this and it interests you, I would like you to click the notification button as well as subscribe so that you will receive content each time is uploaded onto this platform. We are looking at advanced level physics, and it is options we are treating this series. We'll be looking at option one, which is energy resources and environmental physics. We'll be treating 2020, 2021, as well as 2022. We'll be treating 2020, 2021, and 2022. We are going straight into the subject matter, and that is June 2022. We'll be looking at question number 8. Question number 8A. It says the following diagram shows the energy flow diagram sequence in the main component of a hydropower plant. This is the question. It has this gravitational potential energy. You have to fill this box, fill this one with forms of energy, and you also have to fill these because we are asked to copy and complete this diagram. You have to copy this diagram and then you complete it. What do we have as the answer? This is the answer. This is the gravitational potential energy of the water in the reservoir is converted to kinetic energy of water as it runs down the penstock. Then when it enters the turbine, it is converted to rotational kinetic energy of the turbine and the rotor. Then we finally have the electrical energy of the generator. So we have two forms of energy: kinetic energy of the water in the penstock and rotational kinetic energy of the water in the turbine, rotational kinetic energy of the turbine and the rotor, which will now give us electrical energy of the generator. Question number 8A Roman 2. 8A Roman 2. It says in one hydroelectric power plant, the height of the reservoir above the tail raised is 56 meters. The average water discharge at the spiral casing every second is 150 centimeters cubed. Determine the power output from the turbine if its efficiency is 72%. Generally, we know that efficiency is equal to power output on power input, all of that multiplied by 100%. Now, what do we have? We have that energy on time is equal to power. But what kind of energy? Potential energy, MGH, on time is equal to power. Why? Because we are asked to calculate power output. So we have been given the efficiency, so we need to work out the power input from the question. We have all that is needed. All the parameters have been given for us to be able to work out the power input. We have MGH on time is going to give us the power input. But also we have it that the mass of the body is equal to the density and volume. So density and volume are sitting in for mass. Again, the equation is rearranged like this: volume on time. Why do we rearrange it as volume on time? Because we have been told that the average water discharge at the spiral casing every second is 150 centimeters cubed. So this is 150 centimeters cubed per second, which is the volume on time. So it's good to know that. Then This is our conversion. This conversion is very important. The volume on time is 150 centimeters cube per second. But remember, we must convert it to meters per second because our working unit for volume is meters cube, is not centimeters. So to convert 150 centimeters cube per second, we will have it as 150 times 10 to the power minus 6 meters cube per second. We have 150 centimeters cube per second is equal to 150 times 10 to the power minus 6 meters cube per second. Now, if we rearrange this equation so that we have power output, because in the place of power input, we have already substituted V on T, all of it multiplied by rho GH. V on T, volume on time multiplied by rho GH has been substituted in the place of power input. So if we work out the power output, we're going to have the efficiency times density times the rate of volume flow with time times gravity and height. If that is well substituted, 72% is equal to 0.72 times 1000, which is the density of water, times the volume rate of flow with time is 150 times 10 to the power 6 meters cube per second, times gravity, which is 9.8, multiplied by the height, which is 56. If we compute that, if we using our calculator, if we compute that well, we're going to have our power output as 59.3 watts. 59.3 watts. We will look at question number 8A, Roman 3. It says distinguish between fossil fuel and biogas. Fossil fuel and biogas. The first distinction is that these ones are very clear. I want just to list them out. The first distinction is that fossil fuel are non-renewable while biogas are renewable. Fossil fuels take long to be formed while biogas are formed recently are from recently living organisms. Fossil fuel has toxic byproducts and ingredients, while biogas is non-toxic. Question 8B, Roman 1. It says large-scale industrial products could be achieved through fusion of small nuclei in which energy is released. That is true. State one advantage nuclear fusion has over nuclear fission as a means of large-scale energy production. Fusion is the assembling lighter nuclides to produce heavier ones, while fission is the splitting of heavier nuclides into fragments, into lighter ones. So why is it that fusion has, what are some of the advantages of fusion over fission? There are a good number of them. We have the first one is that the end product of nuclear fusion are not radioactive. Therefore, they do not pollute the environment like fission. An example of a fusion reaction is when hydrogen comes together to form helium. But an example of fusion is when uh, uh, uranium reacts or is bombarded with neutrons to produce a krypton and barium. So fusion, the end result pollutes the environment, but for fusion, the end result is what? We have water. The end result is not radioactive, does not pollute the environment as it's not radioactive. What is another difference? The energy release per mass of fuel for fusion is greater than the energy release for fission. It means fusion generates greater energy than fission. The last advantage of fusion over fission is that the fuel that is needed for it is from water. It is cheaper and is abundant. Deuterium is hydrogen too. We can get it directly. deuterium can be gotten directly from water, but the fuel that is needed for fission is from uranium, and it's expensive to treat to enrich it before we can start producing energy from fusion. So we see that the source of fusion is readily available, but the source of fission is more expensive and scarce to find. Question number 8b, Romans 2. We have an equation which we are asked to compute. We have an equation which we are asked to compute. And this is the equation that is loaded. It says the following equation shows a typical fusion reaction. We have hydrogen 2 plus hydrogen 3. Hydrogen 2 is called deuterium and hydrogen 3 is called tritium. It reacts, this is fusion, fuse together to form helium plus neutron and energy. So calculate the average energy delta E that is released. We have the mass of hydrogen 2 is given, the mass of hydrogen 3 is given, the mass of helium is given, and the mass of the neutron is given. So how do we go about doing this calculation? We know that from this equation delta E is equal to delta M times 931 mega electron volt. This is a general equation that we know. I'm sure we are all familiar with this equation. Then what else do we have? We have that this delta M is the mass of the reactant minus the mass of the product. The mass of the reactant minus the mass of the product. These are the reactants and these are the product. Their various masses have been given in this table below. So if we do our arithmetic correctly, this is the mass of hydrogen 2 plus the mass of hydrogen 3. This is the mass of helium plus the mass of uh, uh, the neutron. So if we do this arithmetic well, we're going to have 0.01219 units. Therefore, the change in energy is this mass defect times 931. This is from mega electron volt. This is delta M times 933 times mega electron volt. If we compute this, we're going to have 2.03 times 10 to the power minus 12 joules. Roman question 8b, Roman 3. It says given that the mass of 1 mole of deuterium is 2.0 grams, how much energy is released per kilogram of deuterium? It's a very good question. What have we been told? What have we been told? We have been told that 2.0 times 10 to the power minus 3 kg. Why 2.0 times 10 to the power minus 3 kg? We are converting these grams to kilograms. It has the Avogadro number of 6.02 times 10 to the power 23 23 particles. 23 particles per mole, has 23 particles per mole. Therefore, 1 kilogram will have 1 kilogram times 2.3 times, this is 10 to the power 23. 10 to the power 23 divided by 2.0 times 10 to the power minus 3 gives us 3.01 times 10 to the power 23 particles per mole. Hence, the energy released per kilogram is what we have calculated per mole times 2.83 times 10 to the power minus 12. This was the energy we calculated from the reaction behind. And the final answer is 8.5 2 times 10 to the power 14 joules. We will be looking at C Roman 1. Question C Roman 1. It says explain the meaning of greenhouse effect. Explain the meaning of greenhouse effect. It is a process by which radiant energy from the surface of the earth is trapped by greenhouse gases and re-radiated back to the earth in every direction. Now we have a kind of a diagram that shows the rays from the sun, they enter the earth. This area, they enter the earth through this area. This area contains green, uh, the greenhouse gases like carbon dioxide. These are the greenhouse gases. This area, this ring around the earth, around the stratosphere of the earth. When the short wavelength penetrate, they pass through this area and they heat up the earth. They heat up the earth now radiate energy to radiant energy, releases radiant energy. As the radiant energy goes up, it is trapped by these greenhouse gases and so is re-radiated back onto the earth, and that is the meaning of greenhouse effect. Greenhouse effect, that's the meaning of greenhouse effect. It is a process whereby radiant energy from the surface of the earth is trapped by these greenhouse gases. Carbon dioxide and other gases form the greenhouse gases. They are trapped so that they can't escape, and they are re-radiated back to the earth in every direction. We look at C2. C2, describe a method that can be used to produce one of the consequences of greenhouse effect. Describe a method that can be used to reduce one of the consequences of the greenhouse effect. What are those methods? Uh, we use environmental friendly sources of energy. Two, we plant more trees to stop deforestation. 4, we reduce our dependence on fossil fuel. And 5, we reduce the production of chlorofluorocarbons, and we also do mass education. People need to be educated on what these greenhouse effects are. We are told to use environmental friendly sources of energy. Why? This carbon dioxide is a threat as it forms a ring around the earth. It does not allow radiant energy to go out. It rather re-radiates radiant energy to the earth. And what happens? It increases environmental temperature. So what should we do to reduce the effect of this greenhouse effect? What should we do? We should use environmentally friendly sources of energy like water, like wind, like tidal variation, and so on. We should also plant more trees. Why should we plant more trees? So that the trees will absorb carbon dioxide in the atmosphere. Why should we stop deforestation? As we cut down trees, we are exposing our environment to much carbon dioxide. We should reduce our dependence on fossil fuel because fossil fuel, they release a lot of greenhouse gases. We should also reduce our dependence on these chlorofluorocarbons. These chlorofluorocarbons, they do a lot of depletion of the ozone layer, which will rather increase the amount of energy entering into the surface of the earth and also will raise up the temperature of the earth. We should also do what? We should educate. There should be mass education because we are told that little drops of water make an ocean. We go to rural areas, people keep burning rubbish. They don't know how to recycle everything they have. They burn around the rubbish, they burn around the neighborhood, and they are stirring up, they are increasing the quantity of carbon dioxide in the atmosphere. So there is need for mass education. We look at now we are done with 2020. We look at 2021. Question 8. Uh, it says differentiate between renewable sources and non-renewable sources, giving one example in each case. Differentiate between renewable sources and non-renewable energy sources. So this is about energy sources. We are asked to differentiate between renewable sources and non-renewable. What are renewable sources? Renewable sources of energy are sources which can replenish or regenerate themselves within a short time. The sun, the wind, tides, hydropower, biomass, geothermal, these are examples of renewable energy sources. Not renewable, yeah, renewable energy sources. While non-renewable sources are sources that cannot replenish themselves within a short time, e.g. coal, it takes a very long time for coal to be formed. Crude oil, it takes a very long time for crude oil to be formed. Natural gas, it takes a very long time for natural gas to be formed. But wind, we readily have wind. Sun, we readily have sun. Hydropower, we readily have it. Biomass and tides, we readily have those ones that can be replenished within a very short time. So those ones are renewable sources of energy. We look at question 8b. Question 8b, uh, find for a windmill the kinetic energy per unit time. Remember, energy per unit time is power. Energy per unit time. The kinetic energy per unit time, P, is given by 1/3 pi r square rho to the power 3. There certainly should be a V. There certainly should be a V, where R is the radius of the blade, rho is the density of air, and the V the speed of this windmill on a day when air has a density of 1.2 kilogram meters per kilogram per meters cube, and the wind is blowing with a velocity of 144 kilometers per hour. If the efficiency of the windmill is 25%, calculate the power output. You discover that in most of these questions, they'll always ask you to calculate the power output. And generally, we know that efficiency is power output on power input. Efficiency is power output on power input times 100%. So I wanted us to get to efficiency. I wanted us to get to this. Although I've started by analyzing the power input, why do I analyze the power input? Because we know that generally efficiency is power output on power input. All of that times 100%. We have been asked to calculate power output, and we have also been given the efficiency, but the power input has not been given directly. There is an equation that is linking us to the power input. What is this power input? Half pi radius square rho times volume cube. Now, we know that the radius is equal to the diameter on 2. So the radius square is diameter square on 4, because when you square the radius, you are squaring the diameter and you're squaring the 2. So it gives us a diameter square on 2. Hence, if we substitute in this equation, we're going to have 1/3, because when you take this 4 and multiply by this 2, you have 1/8 pi d square rho v to the power cube. Given that the diameter is 4 meters, the density is 1.2 kilograms per meters cube, the speed is 144 kilometers per hour, which when converted gives you 40 meters per second. It implies that the power input is equal to 1/8 pi times or diameter square is 4 meters times 4 times density times the speed to the power cube. It will give us 4.8 times 10 to the power 5 watts. This is the power input. Now, since we already know that efficiency is equal to power output on power input multiplied by 100, then we work out the power output, which is just equal to the efficiency times the power input divided by 100. Efficiency times the power input divided by 100, because we want to make uh, power output the subject of the equation. We multiply by power input and we divide by 100. So if we substitute 25% for efficiency times the power output, which is what we have calculated up here, 4.8 times 10 to the power 5 watts, and divide it by 100%, we will have 1.2 times 10 to the power 5 watts. 1.2 times 10 to the power 5 watts. That is the power input. We will look at C Roman 1. It says, draw energy flow diagram of a hydroelectric power plant. We are required to draw an energy flow diagram. We are required to draw an energy flow diagram for a hydro power plant. Now, this is our energy flow diagram. Our energy flow diagrams is telling us that we have gravitational potential energy of the water in the dam. Then when it runs down the penstock, the gravitational potential energy of the water in the dam is converted to the kinetic energy of the water in the penstock. As it gets into the rotor and to the turbine, this energy, the kinetic energy of water in the penstock is converted to the rotational kinetic energy of the turbine. Remember, the turbine is also connected to the rotor. So the rotor is sitting in between the pole pieces of a magnet. We now have the kinetic energy of the rotor in the pole pieces of a magnet, which when rotating now generates electrical energy. So we have gravitational potential energy of the dam to kinetic energy of the water in the penstock to rotational kinetic energy of the turbine to kinetic energy of the rotor in the pole pieces of a magnet, and from there now we have electrical energy. Next question is C Roman 2. It says, state one environmental problem that arises from the construction of hydroelectric power plants. It looks like a human and economic geography question in secondary school in Form 5. It looks like a human and economic geography question. It says, state one environmental problem that arises from the construction of a hydroelectric dam. We have uh, we have a good number of them. Uh, Let me just release them so we can now go step by step. Now, when dams are constructed, what are the problems? The breeding span for mosquitoes thereby increases the rate of transmission of malaria on people. The breeding span increases. We will have lots of mosquitoes around the dam, and this is going to be a problem. What problem will it create? Is the rate of transmission of malaria will also be increased. What is another problem? It can result in loss of human life. People can fall into the dam. There are people who sometimes they go adventuring, they say they want to swim and then they can get drowned in the dam. Destruction of habitat. For you to construct a dam, you need to destroy farmland, you need to displace people in order to construct the dam. Overflow leads to soil erosion. When there is an overflow, it will certainly cause soil erosion. It harm water quality. The quality of water is affected. It obstructs fish migration. When the dam is blocked, fish no longer have it easy to migrate. It diminishes recreational benefits of rivers because dams are constructed along a riverside. So people could have been moving up and down the river doing lots of recreational activities, but the dam now has come to block the flow of the river, and so the recreational benefits of the river are maybe destroyed. It increases sound pollution. It increases sound pollution. The volume of water flowing now around will increase sound pollution. We look at D Roman 1. It says, explain why, explain what is meant by global warming. What is global warming? Okay. Uh, Global warming is the gradual and recorded increase in the average global surface temperature as a result of infrared radiations trapped within its atmosphere by greenhouse gases. Look at that definition. It's quite good, elaborate, but it's good and it's explicit. Global warming is the gradual and recorded increase in the average global surface temperature. It is the gradual and recorded increase in the average global surface temperature. Remember, we are dealing with global temperature. Increase in the average global surface temperature as a result of infrared radiation trapped within its atmosphere by house effect. Now let us uh, the next question D2. It says state and explain one effect of global warming on human being. State and explain one effect of global warming on human being. I think I had three. High temperature. As heat is prevented from escaping the Earth's atmosphere, temperatures increase. Severe storm and flooding. Increase in temperature causes changes in rainfall. This result in more severe storm. Ice melting. Increase in temperature causes more ice melting, and it will further go to cause flooding. 2020, we are looking at 2020. We are done with 2022 and 2021. So we are looking at 2020 options still. Please, if you get interested with the content, I would like you to subscribe and hit the notification bell so that when next we upload content, because we will have to look at communication, we will look at electronics, and we are also going to look at medical physics. Uh, 8A of 2020. It says this figure that we have, figure 10 shows a photovoltaic plate used to light a bulb in a certain house. This is the plate, this is the plate, these are connecting wires, and this is the bulb. The solar panel has a power output of 50.0 watts. If the efficiency of the panel is 30%, determine the power input into the photovoltaic plate. Take the question again. This diagram shows a photovoltaic plate used to light a bulb in a certain house. This is the diagram. This is the plate. These are connecting wires, and this is the bulb. It says the solar panel has a power output of 50.0 watt. If the efficiency of the panel is 30%, determine the power input into the photovoltaic plate. This one is a very direct question, and we don't need much to belabor the point. Efficiency is a power output on power input, all of this times 100%, or power output times 100% divided by power input. And so if we are asked to calculate power input, we make it the subject of the equation, which becomes power output on efficiency, all of this times 100%. We have been given power output is 50.0 watts, efficiency is 30%, or if we substitute into this equation, we will have 166.7 watts as the power output. Romans 2, it says, above the Earth's atmosphere, the solar constant is 1.4 kilowatts per meter square. However, only 40% of this power per unit area reaches the Earth. Estimate the surface area of the panel in figure 10, the figure we just viewed. Estimate the surface area. What you must understand is that we are told that only 10% of this power reaches the Earth. It means that 40%, only 40% of this 1.4 kilowatts per meter square reaches the panel. That is what we should have at the back of our minds. That is what you should have at the back of our mind. So we know that the solar constant is equal to power input divided by the area, and therefore the area is equal to the power input divided by the solar constant. But we have been told that only 40% of this quantity reaches the solar panel. So the solar constant value reaching the solar panel is only 40% of this. So we must calculate it. Therefore, it means that then the solar constant is only 40% of this 1.4 times 10 to the power 3 watts per meter square. Why 1.4 times 3 to the power 1.4 times 10 to the power 3? Because we were given in kilowatts. So that is why we multiply by 10 to the power minus 10 to the power 3. If that is well done, we will have 56. We will have 560 watts per meter square. Beautiful. Therefore, this area is equal to the power input that we calculated, which is 1.66 times 166.7 watts divided by the 40% of the solar constant. And what do we have? We have the area as 0.3 meter square. I wanted to look at this question again. The solar constant is equal to power input on area. Therefore, the area is the power input on the solar constant. But we were told that only 40% of this solar constant reaches the earth. So only 40% of this solar constant reaches the solar panel. So the 40% of this solar constant is equal to 40% of this 1.4 times 10 to the power 3 watts per meter square. This 2 is supposed to be up here. It gives us 560 watts per meter square. Therefore, the area, which is our area, which is power input on the solar constant, is 166.7. This is the value we calculated a while ago. 166.7 divided by 560 is going to give us 0.3 meters square. That's the area of the panel. Romans 3. Explain. Romans 3 says, explain why solar energy is referred to as renewable source of energy. Why is it referred to as renewable source of energy? Solar energy is inexhaustible. It is naturally replenishable by the sun. B1. What is ozone layer? What is the ozone layer? The ozone layer or the ozone shield is a region of the Earth's troposphere that absorbs most of the sun's ultraviolet radiation. It contains a high concentration of ozone. What is ozone? An allotrope of oxygen. That is oxygen 3. 3 atoms of oxygen bonded together form ozone, which is an allotrope of oxygen. Now, in relation to other parts of the atmosphere, I wanted to look at this. This is our atmosphere. This is the Earth. Above the Earth's atmosphere, around the troposcope, you have this stratosphere which contains the ozone. What does it do? You see that it reduces this ultraviolet radiation and it completely blocks this ultraviolet radiation. So that is what ozone does. It's a shield. I wanted to look at this other diagram again. You have the sun, and this is our Earth. This bright color, this bright region shows ozone. This is the ozone layer. This is the ozone layer. What does it do? How does it help us? You see this ultraviolet radiation, the intensity has been reduced by this ozone layer, and yet still you see this ultraviolet radiation, it has completely been blocked just like this other one. So the ozone layer helps us to block this dangerous ultraviolet radiation from reaching the Earth. It is what? The ozone layer is what? It is a shield, a region of the Earth's stratosphere, a region of the Earth's stratosphere that absorbs most of the sun's ultraviolet radiation. It contains a high concentration of ozone in regions in relation to other parts of the atmosphere. It means that there are areas of the atmosphere where this ozone, the concentration of this ozone is high, and other areas is not high. You have this is the troposphere, this is the stratosphere, and above it you have the ionosphere. So why do we say in relation to other parts of the Earth's atmosphere? Because it is only around the stratosphere where we have the ozone. B, name a substance which is responsible for the depletion of the ozone layer and explain how this substance contributes to the depletion of the ozone layer. Name a substance which is responsible for the depletion of the ozone layer and explain how this substance contributes to the depletion of the ozone layer. We have uh, we have the depleting substances include this CFS is chlorofluorocarbon, HCFS is hydrochlorofluorocarbons, we have methyl bromide, we have methyl chloroform, and we have methane. These are the substances one, two, three, four, five that I've listed for. Now, how do they affect this our ozone layer? I've done a little bit of kind of an in-depth description. It says that the upper stratosphere consists of considerable amount of ozone, as I showed you in the diagram below. The diagram we just passed, which protect us from the harmful ultraviolet UV radiation of this wavelength coming from the sun. The main reason for this depletion is the CFC, the chlorofluorocarbon. When when released into the atmosphere, that is the chlorofluorocarbon, it mixes with the normal atmospheric gas and eventually reach the stratosphere. In the stratosphere, they get broken down by powerful UV radiation, releasing chlorine-free radicals. This is the reaction with ultraviolet radiation producing this chlorine radical. Now, what happens? The chlorine-free radical, this is the chlorine-free radical, then reacts or attacks the stratospheric ozone to form chlorine monoxide radicals. These are chlorine monoxide radicals and molecules of oxygen. So the chlorine radical attacks the ozone and produces a chlorine monoxide and oxygen. The reaction of this monoxide with atomic oxygen produces more chlorine radicals. So you see this is the monoxide reacting with oxygen, produces more of these radicals. So what happens again? The chlorine radicals are continuously regenerated and cause the breakdown of ozone. Thus, CFCs are transporting agents for continuous generating chlorine radicals into the stratosphere and damaging ozone layers, thus causing its depletion. So the long and short of it is that the ozone is being attacked by these CFCs. The ozone is being attacked by these CFCs, reacting with the oxygen and depleting it because the ozone is three carbons of oxygen bonded together. But these free radicals, when they are broken down, when the chlorofluoro uh, the carbons are broken down by high ultraviolet radiation, forming these radicals. The radicals then attack the chlorine. So this CFS, they attack the oxygen, sorry, they attack the ozone, depleting it. They attack the ozone, reducing it to oxygen. And then the radicals also keep attacking the ozone. They keep reacting with oxygen, with the monoxide of the chlorine monoxides keep reacting with oxygen, producing further radicals, which will go again and attack the ozone. So that is how the depletion occurs. B. Romans 3. State two effects of this depletion, state two effects of the depletion of the ozone layer in on the life on Earth. What are the effects of this depletion? It causes global warming, it causes skin cancer, it causes breathing difficulties, it damages the eye, skin cancer. We have what? Global warming, skin cancer, breathing difficulties, damages the eye, skin burns, destruction of marine life. See Roman 1. Give two reasons why Cameroon relies more on hydroelectric power plants for the supply of electricity instead of fossil fuel. Give two reasons why Cameroon relies more on hydroelectric power plant for the supply of electricity instead of fossil fuel. We have some reasons. Water is free. Water is free. Water is available. Hydropower plants don't deplete the ozone layer. Hydropower is easily transportable by cables. Its production capacity is much higher than that of fossil fuel. What are the advantages of Cameroon using hydroelectric power plant? Water is free, water is available. Hydropower plants do not deplete the ozone layer. Hydropower plant is easily transportable by cable, and uh, its production capacity is very high. Please, once more, if this content, if you were blessed by this content, if you like this content, why not uh, subscribe and click the notification button, because we will be uploading content on electronics. We'll be uploading content on communication. We'll be uploading content on medical physics, and even on the other sections of paper 2. We will do well to also highlight some key issues on paper 1. So I would like you to subscribe and hit the notification button. Roman 2. Give one example of a greenhouse Give one example of a green source of energy. First of all, what is a green source of energy? It is good to know what a green source of energy is. These are energy types that are generated from natural resources. These are energy types that are generated from natural resources. So they're asking you to give one example of a source of energy that is generated naturally. So you have sunlight, you have plants, you have wind, you have tidal variation, you have biogas. These are sources. Give example of green sources of energy, the sources from sun, from plants, from wind, from tidal variation, from biogas and geothermal.